Hello, everybody. My name is Kwasi Nensa. I'm going to give you a brief overview of the asynchronous and reactive programming mechanism in the Oracle JDBC release 23. We will show how you can use those mechanisms to support standard programming, but also the new database pipelining feature of the Oracle Database 23C. So what are JDBC reactive extensions? Those extensions were built into the JDBC driver starting release 21C. It is an implementation of the Java Util Concurrent Flow API. So as you probably know, the Java Util Concurrent Flow interface, it's an interface, there is no implementation. So you have to implement the publisher and the subscriber. So that's what we did for JDBC. And it requires to use JDK 11. In other words, the OJDBC 11.jar, which is the jar compiled with JDK 11. But it works with higher version of the JDK as well. It's validated. I mean, you can use it with higher version of the JDK, but it has been compiled with JDK 11. That's why it's named OJDBC 11.jar. So in a nutshell, if you're familiar with JDBC, you know that we have execute update, execute query. So we just added a suffix async oracle to the standard JDBC API. So whenever you use execute async oracle, you are using the reactive extension, or you use execute update async oracle, you are using the reactive extension. So this is a mechanism where you make a request and it returns immediately. You are not blocked waiting for the database response. When the database response is ready, by a callback mechanism, the client will be notified. In fact, where JDBC uses a selector, a single selector for the entire driver. And as soon as there is a notification, the selector will issue a callback, and that will go back to the requester, right? So those extensions work seamlessly with the reactive streams libraries, such as Reactor, RxJava, Akka Streams, Vertex, Spring Webflux, Hibernate Reactive, etc. We furnish a flow adapter class to allow you to convert flow.publisher types into org reactive streams types. Okay, you can see more detail as the link, the tiny URL at the bottom of the slide. R2DBC is a de facto standard for sort of reactive streams programming across different vendors. You know, all database vendors have a reactive an R2DBC driver. So the Oracle R2DBC driver is our implementation of the R2DBC SPI. And as we speak, we have released the v1.2.0, which implements the 1.0.0 release version of the R2DBC SPI. So we added support for pipeline database calls and also option to give optional values for supplier and publisher, right? So R2DBC, as I said, is a sort of de facto reactive streams implementation support for database vendors. Okay. Reactive extension, UCP reactive extension. So you probably are aware that we also have a connection pool that we call UCP. And in this release, in the JB23C release, we added an extension to UCP to do a reactive connection request. So when you need a connection and you issue a request, UCP will process that asynchronously. So the way it works is you need to use either a UCP connection builder or you use the UCP-XE connection builder, depending on whether you need a vanilla connection or you need an XE connection, depending on your transaction requirements. Okay, then it will asynchronously use either a completable future or a publisher. Publisher, remember this Java util concurrent flow. So UCP supports both mechanisms, either a completable future or a publisher. For XA, it will do an XA UCP-XA connection builder using a completable future for an XA connection or the publisher for an XA connection. Right. So the synchronous borrow operation is used by default the fork join executor, fork join pull executor, but you can specify an executor yourself, by using this interface, the Java util concurrent executor interface. So if you don't provide an executor, we will just use the default fork join pull executor. Okay. So the completable future or the publisher are notified when the borrow operation is complete. That means when your connection is available for use, and at that stage, you can just perform your normal connection pull operations, right? So now these are compatible. The UCP extension is compatible. Reactive extension is compatible with R2DBC connection pull, and I put the link down there. You can see more code sample in the UCP developers guide. JDBC support for V2 So the future of Java scalability is V2 threads. That's coming from the Java SE organization, right? Which controls the future of the Java specification by working with partners, etc., and large companies, etc. So instead of doing reactive stream programming, which could be challenging, right? Virtual thread allows you to use the classical synchronous programming. However, you can get all the benefits of reactive streams. So the motivation for using reactive streams is because OS threads are expensive, right? So you don't want to use a lot of OS thread because it's expensive. It impacts your scalability and OS scheduling, etc., etc. Whereas with virtual thread, well, the JVM can create thousands of them. We don't care because you only use an OS thread when a virtual thread needs to be actively, doing some operation. Otherwise, you can have a bunch of threads waiting to get the OS thread. And even if you block on a virtual thread, it doesn't matter because we have 1,000 of them. So you can waste some of those virtual threads. So that's the motivation, okay? So the JDBC driver has been instrumented with virtual threads in 21.1 release. We have been following the Project Loom specification. And as they change the API, we also change. We all know that JDK 21 will be the first release where the virtual thread will be, I'm guessing, if not production, at least developer release. So we are following that, and we are supporting the latest version of the specification in our JDBC, in JDBC 23C. The benefit of that is the driver will not cause any thread pinning. Thread pinning with the thread will be holding onto the OS thread. So that's not going to happen. And with virtual thread, asynchronous APIs such as reactive streams can be translated into synchronous code. And we show you an example when we get to show the example with pipelining using database pipelining. In fact, we will just block execution until the synchronous result has been received, right? And you can see more details by going to my blog post where the link is down there on the slide. Okay, so now I'm going to show you how we can use all those mechanisms to support the Oracle database pipelining operations. So what are database pipelining? Database pipelining, as you can see on the pictures on the right of the slide. So traditionally, without pipelining, interaction with the database is request, response, request, response. So you make a request, you block until the server responds, right? And during that time, the client, the JDBC, the Java application is blocked. Nothing happens, right? You wait until you get the response from the server, right? So that's a succession of request, response, request, response. Now, with pipelining, you issue a request and you return immediately. You don't wait for the database response. This way, you can use your time, since you have control, control is returned back to the requester, you can issue another database request or do something else. And when the response from the database is ready, you will receive the response. We have some callback mechanism that can be used to give you the response. And that's exactly how we will see how we use the JDBC Async mechanism to support database pipelining. Okay, and we also support that for batch APIs, but that's under the cover. But I will show you one slide on that. Okay, so the benefits of pipelining is it improves response time and throughput, right? It's particularly useful when your network latency is high, right? So that will increase your scalability. Okay, so what is the scope of database pipelining? When do you want to use it? I already mentioned it, but it can be when you need to perform small operations in rapid succession. This is an example of OCI statement execute, but you can translate into JDBC execute, right? Okay. And then if you have DDL, DML, SQL queries, PL/SQL queries, array insert, etc., etc. Okay. So if you have fetches from two different statement handles, those can be pipelined as well. However, it's more performant when the server is distant, when network latency is high. Pipelining is less performant when each operation has a dependency on the result of the previous operation. So if you have a dependency on the results of a previous operation, you have to wait till you receive the response. So in that case, pipelining might not be optimal. It will not work. You won't get any benefit. Okay, so in this example, we are showing how we can use the JDBC reactive extensions to support pipelining. So remember, to support pipelining, you need an asynchronous mechanism on the client side. So you need to be able to issue a request and return immediately and issue another request, right? So that's how you can leverage pipelining, okay? So in this example, we have 3 prepare statements for one delete statement, delete a SQL query, a SQL statement, insert SQL statement, and a select SQL statement. And you can see that here we are using the reactive extension. How do we get to the reactive extension? You can see the execute update async Oracle here. This is an API from the reactive extensions. How do we get there? Well, you get your JDBC connection, you unwrap the connection, and unwrapping the connection allows you to access the reactive extension API. So we do the same. So by issuing this call, it will return control immediately to the Java program. So the Java code can issue another request using the async API, the reactive extension, etc., etc. Then, and the code is not shown here, you need to subscribe to publishers to get the result back, right? So because, when you invoke those APIs, they return a publisher, right? You can see here we are returning a publisher. So you need to subscribe. A subscriber needs to subscribe to those publishers to get the results back. Okay, that's in a nutshell how you would use reactive extension with pipeline database operations. Okay, you can also use reactive streams libraries. And in this example, we will be using a reactor, project reactor. So project reactor has Flux, which is a streaming type where you have multiple items in the flux, in the streams, right? And also have a monotype where a single object. So if we read this code, we start, it's a flux using the using method, and we will execute the prepare statement. And from the prepare statement, we get a mono. A mono is the result set. We get the result set back from the execution of the mono. And then we use the flat map. Flat map will get the stream of items and deliver one item at a time. It will deliver multiple items, from the result set. And those items will be consumed by the subscriber, and the subscriber can print the rows. So when you issue your flux using blah, 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 until the prepare statement, it will return immediately. And then the subscriber will be able to get the result set from the flat map. Okay. Thank you. And similarly for the insert statement, you can see here we have a mono. When you issue a DML, it returns one response, right? When you issue an insert statement, it returns you a number, which is how many rows has been inserted. And that's why we are returning a mono here, and the subscriber can get the mono and can get the value and print it. Okay, so that's how we would use reactive streams libraries to support pipelining. Last but not least, virtual threads and pipelining. Okay, so remember we need an async mechanism on the client side, but virtual threads are not asynchronous, right? And we need an asynchronous mechanism in order to issue a request, return control immediately, and issue another request. So here we are combining the reactive extension. Virtual thread is not asynchronous, but we need an asynchronous mechanism. So we will use the reactive extension, which return control immediately. To use virtual thread and pipelining database operation, remember we need an asynchronous mechanism. So here we will be using project reactor. So the project reactor, we will consume the results synchronously with project reactor by blocking. We block here until the result of the operation is received from the database. So we make asynchronous call by using the reactive extension here. Okay, and here, in order to consume the results, we use project reactor and we block, waiting for the response from the database, from the operations. Okay, so that's how we can use virtual thread and combine with reactive mechanisms such as reactive extension or the project reactor. Under the cover, when you use a batch API, we also generate a synchronous call for you, but that's internally. It's not something you have to code. You just need to use the standard JDBC batch API, and the driver will, under the cover, generate asynchronous code for you. So because if we don't do that, when you use batching with pipelining, the driver sends the operation one after the other. But if we want to benefit from pipelining, we need to use an asynchronous mechanism to send the statement to the database, right? So that's why we are generating an asynchronous code under the cover, right? Okay. So this is a summary of all the database access mechanisms for the Oracle JDBC, both synchronous and asynchronous. So as of DB23C, to read this slide, look at the user Java code. It's a blue box. That's your code, right? And in that code, you have your business logic, your application, but you also have libraries. So you are invoking libraries. You are pulling some APIs, right? JDBC or Reactive extension, or even R2DBC or other third-party Reactive Streams libraries. Okay, so that's your Java code. So from the bottom to the top, we are using the synchronous blocking JDBC call. That's the traditional vanilla JDBC synchronous call, right? So that's familiar. A little bit higher here, we are using the async call with non-blocking back pressure. That's the Reactive extension. It's an implementation of the flow, which is Reactive Streams interface flow, right? Async call with non-blocking back pressure, okay? But if you go even higher and you pull in either R2DBC or third-party Reactive Streams libraries, those are implemented, interoperate with the Reactive extension. So now you have full Reactive Streams with map, reduce, operator, or concurrency modeling, etc., etc. Now on the right, it's a database, right? The database can be accessed with database pipelining or without database pipelining. Obviously, if you are using the synchronous call, you cannot do pipelining, right? So you can only do without pipelining. But if you're using the Reactive extensions or Reactive Streams libraries, you can access the database using pipelining, as I just explained. Okay, thank you. This is a reference to my technical brief, which gives you all the new features for Java in DB23C. And this is also our JDBC landing page where you have everything we have published. Okay, videos, blogs, etc., links to Maven Central, to documentation, etc. This is my Twitter handle, and this is our hashtag where we tag everything we post with the Java Oracle DB, Oracle DB with this hashtag. Okay, thank you.